Okay, number one, we see it's in standard form, so I'm going to start off with the negative b over 2a to find my axis of symmetry. So negative 16 is 16 over 2 times 4 being 8. 16 by 8 is 2. So x equals 2 is my axis of symmetry. So my vertex 2, comma, and then I'm going to plug it in. 2 squared is 4 times 4 gives us 16. 16 times 2 is 32, so minus 32 plus 3. 16 minus 32 is negative 16. Negative 16 plus 3 is negative 13. Max or min? Well, the a value is positive, so I know this is opening up. So the vertex is at the bottom, which is a minimum. That minimum value, it's whatever your y coordinate of your vertex was, negative 13. Y-intercept is, since I'm in standard form, it's just whatever your c is. It's 3. And you could do 0, 3 if you want. Domain range, let's come back to those. Let's go ahead and do a table of values to find some more points so I can graph. So I'm going to surround to 2, I'll go 3, 4, and then on the other side I'll go 0, negative, or sorry, 1, 0. I already know what 0 is. That's my y-intercept, it's 0, 3. So I can go ahead and put those in my table. Let's plug in 1. 1 squared is 1 times 4 is 4. Minus 16 times 1 is 16 plus 3. So 4 minus 16 is negative 12 plus 3 is negative 9. Okay, I may need to change my scale, and I know this graph didn't print off very well anyway, but 1, 2, maybe 3, 4, 5, 6, 7, 8, 9. Yeah, I might go by 2s here. So I'll change both scales to going by 2s. So 0, 3, about there. So 4, 3, 2, 4, 1, negative 9, 1, negative 2, 4, 6, 8. So about there. And then 3, negative 9. So then 2, 9. So 10 to 12, roughly there. Especially with our graphs not being perfect, it's going to be, you know, you get the idea. It's not going to be perfect. But hopefully it should look something like that. Now, as far as the domain of a parabola is always all real numbers, because there's no x or no x value you can't plug in. But as far as y values, there was a minimum to it. Negative 13 was the minimum. We can't plug in anything less than negative 13. Everything greater than that gets graphed. So we would say y is greater than or equal to the negative 13. Now number 2, this is vertex form. This is section 4.7 right here. So pretty recently. It's the one with the h and the k and the a in it. So if it's in vertex form, I can quickly pull out the vertex. You take the h, we have to do the opposite sign, so positive 3. And then your k is the constant at the end. Don't change its sign, it's 6. So then your axis of symmetry, work backwards. The vertex, I didn't even write it on number 1. The axis of symmetry and your vertex, the x-coordinate of your vertex, were the same when we were in standard form. They're the same when you're in vertex form. So we know the vertex is 3. Our axis of symmetry is x equals 3. We don't have to do a negative b over 2a thing. Max or min? I see it's negative, so it's opening down, which means the vertex is at the top, so it is a maximum. That maximum value is the y-coordinate of the vertex, 6. Y-intercept, this one's not quite so easy now that we're not in standard form. You have to plug 0 in. In the parentheses, 0 minus 3 is negative 3. Square it, we get 9. Times negative 2 is negative 18. I got negative 18 plus 6, that's negative 12. Domain, all real numbers. Range, I haven't even graphed it yet, but we know that this was a max, so y has to be less than or equal to the 6. Make a table of values. The vertex in the middle. 4, 5, 2, 1. My y-intercept is probably off my graph, that's why I'm not going to bother using it. I'll just use these other ones. So plug in maybe 4. 4 minus 3 is 1. Squared is 1 times negative 2 is negative 2. Plus 6 is 4. Plug in 5. 5 minus 3 squared. So 2 squared is 4. Times negative 2 is negative 8. Plus 6 is negative 2. So 1 negative 2 and 5 negative 2. I'm probably going to have a couple points here. We'll go, okay, 2, 4, 1, 2, 3, 4, and 4, 4. And 3, 6. Oops. There we go. We're going to solve by factoring our square roots. This first one looks factorable. X minus 1, x minus 8. So we got to solve, so go the extra step. X is 1 and positive 8. This is a difference of two squares, x plus 6, x minus 6. So we get negative 6 and positive 6, or I could say plus or minus 6. We also could have solved that by square rooting, add the 36 over in square root. So I'm going to add the 1 over. Like that, equals 0. Looks like it's going to be, we know we're going to have to end in 1s. They're going to have to be negative 1s. So it looks like it's going to have to be 4x and 2x. Multiply to make it 8x squared. Negative 6, negative 4, negative 2 makes negative 6. Okay, so that's going to work out. So now set each factor equal to 0. 4x minus 1 equals 0. Add 1, divide by 4, so we get 1/4. And then on this one, add 1, divide by 2, we get 1/2. Add the 24x over. Add the 16 over. Okay, so this one, I've got to think of numbers that multiply to 9. Could be 1 and 9, could be 3 and 3. For 16, could be 1 and 16, 2 and 8, 4 and 4. I'm going to try 3x and 3x. I'm going to try 4 and 4. They're both going to have to be positives because I know they multiply to a positive and the addition is positive also. So here I would get, outside of FOIL I get 12x, inside I get 12x. 12x and 12x do make 24x, so I got it right the first time. Now that's actually the same factor twice, 3x plus 4 squared, so I only have to set it equal to 0 once. And so then subtract 4 divided by 3, we get negative 4/3 for our one and only x-intercept. The only solution. Okay, go-kart race. 380 races per week. They charge $35. So our revenue, let's do racers. 380. We're going to gain 20 racers per week though with each increment in price change. So add 20x. And then the price was 35, but I'm reducing it by $1, so I'm subtracting 1x, x number of times. So there's our equation. What should the owner charge to maximize revenue? We need to find the vertex here. So we can FOIL this out and do negative b over 2a, or we can use a graphing calculator. Either option is acceptable. Okay, on the graph, we're going to have to change our window. I probably should have done that before. Wait for my spinning wheel to stop so I can change my window. I'm going to leave my x max, min and max alone for a moment, but I know it's the y max. Right now we're charging $35 a race for 380 racers. We're getting huge numbers already, and we're trying to go up from there. So I don't know, let's just try like 2,000. That might be not really what we want, but we're going to give it a shot. Okay, we'll go scale by 100. Let's try that. Yeah, I think we really needed to go 380 times 35 is going to be more like, we need to go way higher than that. So let's try like, let's try like 16,000 or something. Let's try it. Okay, we're looking for the maximum. Oh, maybe I need to go further to the right with my x's. So let's try 20. Okay, it's going back down. So now we can get our maximum. So I'm going to go to calc, maximum, left bound, right bound, guess. So 8, 14, 8, 580. So the vertex, I'm just going to jot this down. 14,580. That's the maximum revenue. That's how high it's going to go. The question is, what should the owner charge per racer to maximize the revenue? So per racer, 8 is not how much we should charge. That's how many increments. We were subtracting $1. We were reducing $1 every time. Starting at 35, we reduced it $1 8 times. So that means we're charging $27 per ride. Maximum revenue. That was the y-coordinate of the vertex. That was the 14,580. City. It's doubling the area of a playground. Currently, the playground is 72 by 48. So it's 3,456 square feet. We want to double it. So we want the area to be 6,912. In case you didn't follow that, I just took 72 times 48 to see what it is now. They say we want to double it, so that's the goal. We want to add x to each of the dimensions. So 72 will now have x added to it. 48 will now have x added to it. When I multiply those two together, it should give me my area, which is the 6,912. We need to solve this for x. So this is not a maximum. We're looking for x-intercepts this time. Chances are one of them is negative, one of them is positive. I want the positive one. So here I do want to FOIL this out, so I can set it equal to 0. So 3456 plus 72x plus 48x plus x squared is equal to 6,912. 120. I'll subtract the 6,912 over, so I get negative 3456 equals 0. And I need to solve this somehow. Factoring if it's factorable, complete the square, quadratic formula, or graphically. I'll just go ahead and complete the square. Half of 120 is 60, squared is 3,600. So we get x plus 60 squared. 3456 plus 3,600, that's going to be what, 7,056. Oops. What are the chances that that's a perfect square? It is a perfect square. Don't forget we have to do plus minus. So x plus 60 equals plus minus 84. So this actually was factorable also, but it's a big number. Now I subtract 60. Negative 60 plus minus 84. So negative 60 minus 84, that's negative 144. Negative 60 plus 84, that's 24. Oops, not. So those are the zeros. Well, obviously negative 144 doesn't work. So 24 is the value of x. Solve. So x equals 24. What will be the new dimensions? Add 24 to 72. So we get 96 feet. And then add 24 to the 48, 72 feet. And yeah, x was 24. Number 9. Shot put still in the air. We got the equation. Okay, how far did the shot put travel? Okay, let's go ahead and graph this. Negative 0.02 x squared plus x plus 6. We'll be able to change our window now probably quite a bit. We're talking a horizontal distance. I'm just going to guess 50 feet or something. I don't know how far he's going to throw it. We're not going to throw it 16,000 feet high though. I'm just going to go with like 20 feet high. He's not going to probably throw it so high. And it's the x-intercepts I'm looking for anyway. So we'll try graphing this. Yeah, okay. Through a little bit farther than I guess, a little farther than 50 feet. So I'll just go 60. Okay, so now we want to know how far it traveled. So we want to know when it hits the ground. We want to know that 0. So really you could use any method. You could use quadratic formula, factoring, completing the square. I'm using the calculator. I'm going to find the 0, number 2. Now I don't care about the negative one, I want this one. So left bound, right bound, I guess. So about 55.43 feet. So that's the horizontal distance. It tells me x was the horizontal distance. That's how far it traveled. Now it says, what was the maximum height? So now I want to find the maximum. So go back to calc and choose maximum this time. Left bound, right bound, guess. And so the maximum height, that would be the y value, 18.5 feet is how high I went. Okay, a factor tree, 48. You can go 4 and 12. 12 goes to 4 and 3. Now the 48, I know it's a negative. And then the 4 and the 12 and the 4, they're all broken down, so don't worry about them anymore. But I have a pair of 2's and another pair of 2's, so I get to pull out 2 times 2, which is 4. Because of the negative, I have to pull an I out. And then this 3 is stuck inside, so 4i squared of 3. That's what we get. Number 11, it's not a FOIL problem, it's subtraction. So subtract like terms. 3 minus 11 is negative 8. 2i minus negative 10i. Minus and negative is like plus. So it's really like 2i plus 10i, which is 12i. There's my answer. Now number 12, I get to FOIL. Negative 20 minus 35i plus 4i plus 7i squared. We know that I squared is negative 1, so this becomes minus 7. So what that equals, combine it with the negative 20, so I get negative 27, and then negative 35i plus 4i, that's negative 31i. Finish with that one. Number 13, I've got to rationalize, so I multiply by 1 plus I, the conjugate, plus 1 plus, sorry, 1 plus I. Go ahead and FOIL. So 2 plus 2i minus 3i minus 3i squared. 1 plus I minus I squared. In the top, negative 3i squared, that becomes plus 3. In the bottom, minus I squared, that becomes plus 1. So 2 plus 3 is 5 minus I. And here the I, negative I cancel, 1 plus 1 is 2. So you can write your answer in that way, I'd probably accept it, or in standard form, which it actually technically says I should do 5 halves minus, and then the coefficient on I is 1, so it's 1/2 I. Oops. Oh, I'm sorry. I did all that without you being able to see. I apologize. I should have looked up there. So that was 1 plus I, foiled it all through. Okay, number 14, complete the square. I'm going to add the 2 over. Half of 8 is 4 squared is 16. I'm adding 16 into both spots. So x plus 4 squared. Over here, 2 plus 16 is an 18. So now I square root, plus minus. X plus 4 equals plus minus. If I factor tree 18, I get 2 and 9. 9 goes to 3 and 3, so I have a pair of 3s I get to pull out. With the 2 stuck inside. Don't put the 3 in front of the plus minus. And then finish this off, subtract the 4, but put it in front of the plus minus. X equals negative 4 plus minus 3 squared of 2. Number 15, I'm going to divide everything by 4, both sides. X squared plus 6x plus 10 is equal to 0. Move the 10 over. Half of 6 is 3 squared is 9. So I end up with x plus 3 squared is equal to negative 1. Square root plus minus. X plus 3 is equal to plus minus square root of negative 1 is I. So subtract 3. X equals negative 3 plus or minus I. Alright, number 16, quadratic formula. Negative 7 plus or minus the square root. 7 squared is 49. Minus 4 times 1 times negative 12. It's all over 2 times 1. So negative 4 times 1 times negative 12, that's positive 48. So that's 97 inside there. Uh, 97 shouldn't be able to simplify down. So looks like that will be my answer. Number 17, x equals negative 6 is 6 plus or minus square. Negative 6 squared is 36 minus 4 times a times c over 2 times a. Um, 4 times 9 times 7 is 252, so I have 36 minus 252, which is negative 216. So 216 actually goes to 6 and 36. It's a bunch of 6s. I'm going to actually circle a pair of 6s. I know I didn't go all the way down to 2s and 3s, but I already know there's 2 6s there. That's fine. 6 goes to 2 and 3, so that's left. So 6 plus or minus. There's an I there as well. So I get to pull a 6 out. I get to pull an I out. And then 2 times 3 gets multiplied back together to make a 6. It's all over 18. Now 6, 6, and 18, they're all divisible by 6, so I need to divide them all by 6. 1 plus or minus I squared of 6 over 3. Don't touch the 6 inside the square, only the coefficient. Alright, number 18, we've got to put it in vertex form. So x squared minus 6x. We're going to be adding a number there. Going to leave this negative 15 out here, and since we're adding in a number on the right, I'm going to subtract the same number on the right. Negative 6, half of negative 6 is negative 3 squared is 9. So I'm adding and subtracting 9 from both sides. So I get x minus 3 squared minus 24. And then find the vertex. 3, negative 24. graph. So I'm going to do negative b over 2a. So I get positive 2 over negative 2. It's negative 1. I'm going to surround it. So 0 and 1, negative 2 and negative 3. When I plug 0 in, that's the y-intercept, I get negative 3. Let's go ahead and plug negative 1 in. Negative 1 squared is 1, but then there's a negative sign in front of it. So negative 1 plus 2 minus 3. So I get a negative 2. Then we can plug in 1. So we get negative 1 minus 2 minus 3. So minus 6. Once again, we got a graph that's not very nice. Okay. Negative 1, negative 2. Negative 2 was down at negative 3 also. Negative 3. 1, 2, 3, 4, 5, 6. And 1, negative 6. It's an inequality, but it is equal to, so I can do a solid line. And then I can test a point. Maybe I would test 0, 0. 0 is less than or equal to, and on the right side we just end up with negative 3. Is 0 less than or equal to negative 3? No, it's not. So 0, 0 is not a solution. Therefore, the solutions are not outside the parabola. They must be inside the parabola. Okay. Number 20, they want us to solve this one by graphing. So, negative b over 2a. We get negative 5. Plug it in. 25 minus 50 plus 7. That's negative 25 plus 7 is negative 18. So maybe I'll plug in negative 3. Squared is 9. Minus 30 plus 7. Negative 14. And then plug in negative 4. Squared is 16. Minus 40 plus 7. Sorry, 23, so should get negative 17. So we're nowhere close to having our intercepts yet, which is kind of unfortunate. If I went out to 0 even, 0 would be at a positive 7, so it's got to be less than 0. Negative 1, we get 1 minus 10, it's negative 9 plus 7, it's negative 2, so it looks like it's probably going to be decimal. But let's go ahead and graph this. Maybe going by 2's here. So 2, 4, 6, 7, 2, 4, 6, 8, 10, 12, 14. Negative 6, negative 17, 14, 16 is about 17. This would be a solid parabola also. Shading, if you could test 0. Let's check 0 is outside of the parabola. Although maybe it's better to plug like negative 2 in, because we know for sure. I'm confident negative 2 is in there. So negative 2 squared is 4. Minus 20 plus 7. It's negative 16 plus 7. It's negative 11. Check and see if it's greater than or equal to 0. No, it's not. So negative 2 is not a solution, so the solutions must be outside. So we have here on the number line, close circle there and there, wherever those numbers are. And we're shading outside. I could use quadratic formula to find out what those numbers are. I'm going to go ahead and leave it like that. But because it's set equal to 0, we're solving. We don't need the entire bottom and top. This graph helped me get it, but ultimately is the number line that I cared about. Number 21. Now I don't have to graph. I can just go ahead and solve algebraically. So I can do quadratic formula. This one's factorable, looks like. It's going to be an x minus 6 plus 3. So my x-intercepts are negative 3 and 6. If I thought about those on a number line, I could put them here. They'd be open circles. I'm trying to decide whether we're shading in between them or outside of them, so I could test 0. 0 is between them. So if I plug 0 in, I get negative 18 is less than 0, which is true. So 0 is the solution, so my solutions are between them. So this is an AND, so we would say negative 3 is less than x is less than 6. Number 22, we got to get that 12 over. X squared plus x minus 12 is greater than 0. Oh yeah. So if we factor it, we get x plus 4 and x minus 3. So our intercepts are negative 4, positive 3, both open circles. 0 is between them. We can test 0 again. We get, if I plug them in right here, I get negative 12 is less than 0, or if I greater than, that's not true. So 0 is not a solution. Those solutions must be outside. So we could say x is less than negative 4, or x is greater than 3.